Welcome to show number 266 of the Arc Junkies podcast, the show that brings you the latest insights and opinions on cutting-edge technologies and ideas that are shaping the future in welding. In this episode, we explore the use of hydrogen as an alternative fuel source with a panel of experts. Joining me today is Scott Witkowski from Republic Testing Labs, Bill Newell from Euroweld, and Mike Miller from CEM Marketing. We dive into the possibilities of using hydrogen instead of fossil fuels and discuss whether the existing oil and gas pipelines can be repurposed for transporting hydrogen or if new infrastructure is needed. We also get a sneak peek into the upcoming hydrogen workshop in Texas that's happening this October. Stay tuned for an exciting conversation that could change the way we power the world. We'll get right into today's episode after a quick word from our supporters. Today's episode of the Arc Junkies podcast is brought to you by Rock Mount Research and Alloys. If you're a maintenance welder, you know that making repairs is an essential part of your job. But let's face it, sometimes those repairs don't last as long as you'd like. That's where Rock Mount comes in. Rock Mount understands the importance of using high-quality welding rods and wires that can withstand the toughest conditions. That's why they offer a range of rods and wires specifically designed for maintenance welding. Rock Mount's products are formulated to give you the best results so you can get the job done right the first time, every time. But it's not just about the quality of their products. Rock Mount also believes in making it easier for their customers to get what they need. That's why you can find a full catalog of maintenance rods and wires at rockmountwelding.com. Plus, when you use code word ARCJunkies10 at checkout, you'll save 10% on all their abrasives, burrs, bits, blades, and welding chemicals. So next time you need to make a repair, don't settle for subpar welding supplies. Choose Rock Mount and weld with confidence. Make repairs that last with Rock Mount Research and Alloys. We're also brought to you by Outlaw Leather. Based in Pasadena, Texas, Outlaw Leather is a family-owned business that provides top-quality welding and ironworking gear. They understand the unique needs of welders and ironworkers and have developed a range of products that are both functional and affordable. Head on over to outlawleather.com where you'll find brands you know and trust like Flange Wizard, Irwin, Empire, Snake Belly, and many more. They also offer a range of customizable gear including hoods, bolt bags, rod pouches, work belts, arm pads, and tool holders. And the best part, all of their products are available for fast, easy shipping so you can get what you need when you need it. And as a listener to the Arc Junkies podcast, you can save even more on your purchases. Just visit outlawleather.com and use code word ARCJunkies in the discount box at checkout and get 15% off all their in-stock leather goods. It's their way of saying thanks for listening and supporting the show. So don't wait. Head on over to outlawleather.com and get the gear you need to work at your best. And if you're local, be sure to stop by their storefront and say hi. Tell them the Arc Junkie sent you. Are you looking for the best TIG welding equipment on the market? Look no further than CK Worldwide. They've been leading the TIG welding industry for over 50 years, providing innovative and reliable solutions for welders just like you. With more patents on product designs and improvements than anyone else, CK sets the standard for TIG welding equipment. Their exclusive innovations like gas saver kits, max flow water cooling technology, wedge collets, flex lock torches, super flex hoses, and fail-safe hose connectors are designed to make your TIG welding process smoother and more efficient. Whether you're a professional welder or a welding hobbyist, CK has what you're looking for. There's a lot of excitement with CK's launch of their new MT375 AC/DC 375 amp welder with a dual pump water cooler, cart, torch package, and more. This new powerful welding machine is being packaged with a newly 2-in-1 steady grip foot pedal that incorporates a fingertip control into a foot pedal for work in both applications. Don't settle for second best. Choose CK Worldwide and experience the difference in quality and performance. With a reputation built on decades of experience and dedication to innovation, CK Worldwide is the only choice for top-of-the-line TIG welding equipment. Upgrade your welding game today and see the difference with CK Worldwide. You can find more information on CK's torches, consumables, welding machines, and accessories at ckworldwide.com. And while you're on the website, hit the Find a Dealer tab to find the closest distributor in your area. CK Worldwide, the standard in TIG welding. And one last thing, I'm getting ready to do a huge giveaway on Instagram for hitting 20,000 followers, so make sure you follow the show and hit that notification button so you don't miss out on this awesome giveaway. I also have Arc Junkies banners coming back up for purchase by the end of this week. The last batch sold out pretty quick, so if you want one, make sure you're checking my stories on Instagram. You can also check out the link in my Instagram bio or in the show notes of this episode. I still have Arc Junkies sticker packs available as well that you can purchase through the same link. Alright, enough logistics. You know what time it is. Fire up your machine, drop your hood, and turn me up 5.
You're listening to the Arc Junkies podcast, helping you make every weld better than your last with each episode. And now your host, Jason Becker.
All right, before we get into this, why don't y'all go ahead and introduce yourselves to the listeners?
My name is Scott Witkowski. I'm the Vice President of Republic Testing Laboratories in LaPorte, Texas. Today we're going to talk about hydrogen.
I'm Bill Newell. I'm Vice President of Engineering for Euroweld Limited. We are a company that offers specialty welding consumables and welding engineering consulting.
Yeah, Mike Miller, VP of Strategic Solutions here at CEM Solutions, a company that offers large events, industrial gatherings, also does a lot of marketing and things like that to help companies grow, but more recently into consulting and educating on topics just like this.
All right, so Scott, tell me a little bit about the big hype around hydrogen. All of a sudden, it's been something that's been utilized in the United States since the 1940s. I know there was the Hindenburg incident. Everybody's pretty familiar with that one. I mean, that's pretty much what people know about hydrogen. But I guess we've had underground pipelines of hydrogen since like the 1960s and been doing a lot of research. And it's not until current day that we're talking about using hydrogen as an alternative fuel source. Probably because, the safety factors and the costs and all that. So what's the big hype with hydrogen now?
I think it's just being driven by the government, wanting to move to a cleaner resource for energy. The wind and the solar things picking up on the fuel cell side is trying to find an alternative fuel that they can burn in power plants and things of that nature and utilize to burn cleaner energy outside of natural gas or crude. So I think cost is one thing that has really driven the industry away from really pushing this from the private sector. Now that the government's kicking in, billions of dollars in subsidies for things like this, a lot of the owner operators are really, jumping on board with, pushing through with the technology. So you're starting to see a lot of talk in the industry now about design. Can the current infrastructure that we have handle hydrogen in its systems at percentages and whatnot that they're talking about using or utilizing and building new systems. Not a lot of people are talking about how to weld for hydrogen service. So that was one of the things that we put our heads together. Me and Bill were talking. It's like, well, why don't we put together a little workshop to try to generate more conversation about the welding. Normally, welding is an after fact when it comes to design of a plant or a system or whatnot for welding. They do a great job on designing all the mechanical and whatnot and all the equipment, and then we get the welding last minute and have to try to figure out how to make it successful. So now we're trying to we want to get ahead of the curve, and we really want to generate more discussion and whatnot. In Europe and Asia, they're doing hydrogen, they're doing welding for hydrogen service and have been. So we're kind of behind the eight ball in the U.S. domestically in North America. That's Canada and the U.S. And so, we want to be in front of it, not behind it. So that's kind of the reason for what we're, why we're here today.
Yeah. That's what one of my biggest questions is, we currently have pipelines for petrochemical and, fossil fuels and all that stuff. So do we just shut that line off, drain it, fill it full of hydrogen, or is that going to work? Because, if you think about how we typically do welding on the pipeline, you're running a 60-10 route, which is a hydrogen-inducing process, which is something we don't want. And then you do a little bit of post-weld heat treatment to bake some of that hydrogen out. You cap it with a 70-18, and then they put some sort of epoxy layering over it. Is that type of weld joint, or is that material that we're currently using even sustainable to transport hydrogen in?
We don't know.
To be continued.
And that's one of the reasons we want to discuss this, because the biggest fear is hydrogen embrittlement. Mm-hmm. And we fight that. Well, we fight it and try to avoid it at all costs. And here, to take an existing line that might be 50 years old, we don't know how it was put in to begin with. We don't know the actual condition of the welds. We don't know the actual corrosion status of the interior of the line. So these are many questions that have got to be evaluated. Now, it's obvious if they can use an existing line, that'd be great, because they don't have to get new right away, don't have to put in a new line. So there's a lot of advantages to that. But I think It's odd. It used to be you might see a paper or a webinar or something maybe once every other month. Now I'm seeing things come across daily on this subject, and there are many more questions than there are answers. And it's like Scotty said, the government is somewhat driving this because they want to lower CO2 emissions. And hydrogen is a great way to do that. We've got combustion turbine vendors building combined cycle systems that can run where you blend hydrogen in with natural gas, and you get a more efficient machine. Some of the utilities are looking at ammonia. Okay, that's hydrogen and nitrogen. And I was wondering, do you run the plant on ammonia? Do you split it off in the end? But there's something that we have to come to grips with. The best way to make hydrogen right now is with electrolysis. In other words, we got to have a lot of electricity. We split it into hydrogen and water, kind of like a reverse fuel cell. And that's all well and good. But when we talk green, the only true green we've got or renewables are like wind, solar, or hydro. Now, I personally think nuclear ought to be in that mix, but some of the environmentalists would disagree with that. But let's just take an arbitrary number. Let's say 20% of the energy in this country is generated by the renewables, solar, wind, and hydro. Well, if we use those to make hydrogen, what's going to replace what they're already feeding the grid? Fossil fuels.
Yeah.
So,
because you can't create energy from expending energy. It's a one-for-one exchange.
Exactly. And so this is not just a, tit for tat. It's a very complicated scenario. And to just jump on the bandwagon and say, oh yeah, we're going to do this. It's like an electric vehicle. Yeah, they're wonderful if you got a charging station and they don't catch on fire. So we've got issues here and the safety side of it. Now, the fact that we have pipelines in Texas and Louisiana, or hydrogen lines, and they've been there for a long time, the owners of those lines obviously have figured out how to do it, because we don't hear of explosions and catastrophic events. And that's a good thing. Some people say, oh, well, it's very dangerous to transport. And I said, yeah, well, so is propane, and we run propane all over the place, and we don't have a problem. So I think it's more of an awareness. Now, Scotty made the comment about welding. When he first approached me on this, I said, well, quite frankly, I'm not sure what to do, but I think I would digress and think about sour service, where we don't want a hard weld. We want a soft, if you will, but yet have enough strength and ductility for the service. And then the more I read about this and try to get learned on it, yeah, it's going to be welding exactly like we do sour service, because we need the same result. However, I think we actually are going to need a little bit higher quality weld, especially in the root area, just because of the hydrogen embrittlement.
Yeah, you get to use a low hydrogen process to put that root in.
Yes.
Such as gas tungsten arc welding or gas metal arc welding or orbital TIG or tip TIG or some process along
yes, that's
those
true.
lines.
Forget 60-10s. That's not in the equation on this.
We don't want to put any hydrogen if we can, or if we can avoid it.
That's a true statement, but we have ways now, and you can use induction preheating and things like that, and we can cook it out real quick. But there's going to be a price to pay for this. This is not going to be like just, walk up to it and weld it. It's going to have to be designed and engineered. And there's going to be an education level on this. And the owner is going to have to ante up and spend some money, because it's going to cost more than a normal pipeline. I think Scotty would concur with that.
Yes, sir.
Yeah, I think I read it's about $1 million per mile to put in a hydrogen line. I was wondering the cost difference between trying to utilize what we currently have. So if we try to use what we currently have, the pipeline system that's already in place, and we're going to have to excavate that. You're going to have to go back through. You're going to have to retest all the welds, test the materials. Bill, like you were saying, look at the interior, find out the corrosion. Then you got to deal with the hydrogen embrittlement factor. I mean, is that hydrogen? How long is that going to sustain hydrogen flowing through it? If it's somewhat, for lack of a better term, caustic to the inside of the material.
Right. And we don't know that. In fact, I saw a fascinating article by a guy that sells pigs to go in pipelines and clean the ID.
Not the oink oink pigs that you're talking about. Elaborate on that a little bit.
Okay, the kind of pig that goes in, and we call it a pig, but it's a device that goes inside the pipe and literally scrubs it and cleans the residue off the interior surfaces. Well, he's looking at this and said, well, we're probably going to have to do this, but he's going to have to come up with a different way of doing it because the normal way isn't good enough for hydrogen service because you've got to reduce the contaminants in there, and then you got to get it out. So there's a lot of ancillary things about this that are really fascinating, and we just don't know. Now, the Europeans, in my opinion, thus far, and I could be proven wrong and probably will be, are way ahead of us. I mean, they've got hydrogen pipelines all over Europe, and ours are pretty much in the Gulf Coast. In fact, I don't know, Scotty, you may have more information on that than I do, but all the maps I see of hydrogen pipelines are either around Corpus Christi or they're going through Louisiana, and that's about it.
Yes, sir.
So far.
Now, are the current, so like for a pipeline, obviously product goes in at one end, it comes out at the other end. Now, if we're going to switch over to hydrogen, does the point of entry, is that a place where we are able to set up hydrogen manufacturing and be able to pump hydrogen into the line? And then when it comes out at the other end, are those facilities set up to receive that hydrogen and do something and distribute it?
Distribution is going to be a big thing. I was at the API 1104 Code Committee meetings a couple of weeks ago in New Orleans, and they've got a task group now formed for, looking at this as well. Currently, right now, your separation companies like your Air Products, Air Liquides, Lindy's, people like that, Messrs, they have plants that manufacture hydrogen, for use in the industries, welding, other related industries. So they've got distribution hubs for all that. They either bottle the gas, keep it in a liquid form or state or whatnot. But, that becomes a big question is right here in the local area that I'm in, there's a couple plants that are slated for new construction in the next 1 to 3 years, for making strictly for making hydrogen. And then distribution becomes a big question. And then if they're going to use it themselves, great. But if they're going to try to sell off extra to other companies to use as a byproduct, how do they get it there? How do they store it? All these things are being discussed right now. But again, a lot of people are not talking about how we're going to weld it. They're, in the last 8 to 9 months, we've gotten inquiries from a lot of construction companies and EPCs, fabricators, engineering firms, like they're currently being asked to put budget numbers together for building plants and pipelines and infrastructure, stations and things of that nature, compressor stations and all that for hydrogen. And they're looking at it exactly as they would for a crude or a natural gas line. And that's not a good idea. But, it's because of the lack of experience or knowledge about it in the industry, which is one reasons why, we all got together and said, man, we need to do a workshop on this and A, generate more questions, or B, try to get some answers and gather a group of professionals from around the world for a day to try to get some answers or kickstart some more discussion to, try to figure this out so it can filter back down to the code committees. So it can be written into practice for future. You're probably going to start to see in the future, you'll probably have recommended practices or documents just for hydrogen welding, I would imagine. Bill, what do you think?
I think we'll see that very similar to the API documents on sour service. And we'll probably see something very similar. They may be identical. I don't know at this point. But yes, we need additional guidance because we can talk about welding all we want to, but somebody's actually got to do it. And that means implementation. And we'll probably have to have some additional training or perhaps come up with a different performance qualification to make sure that the welder is actually doing what we need him to do. So it's not going to be business as usual. It will be a challenge.
So you're going to need a higher caliber welder at the end of the day, somebody that's a little bit more proficient with the welding process, a little bit more familiar with the different variables. I would imagine that a lot of this is going to end up being mechanized just for repeatability.
Yeah,
Yeah.
yeah, except for maybe, compressor stations and things like that, where you just, it's hard to mechanize. And that brings in another variable. If you're going to mechanize, now you're talking portable machining, which of course the pipeliners are well adept at. Your fit up if you go machine, your fit up is even more critical. So, it's kind of like a domino effect in that we have all these additional factors that we have to bring into play.
Now, Scott, have you guys over at Republic, because you do a lot of different weld testing, have you guys started experimenting with different processes and procedures on how to join? I mean, hell, do we even know what material is going to be best to house the hydrogen?
So a lot of the information that's been out there is like Bill was saying earlier, it's a lower strength material is probably, recommended, because the higher strength material is going to be more susceptible to hydrogen induced cracking, right?
Mm-hmm.
So,
Yes.
so, like an A53 or an A106 grade B X42 pipe, it's just simple everyday carbon steel that's used throughout the industry. Filler metal could be a 70S3, 70S6 type filler metal if it's TIG or MIG. For stick, I would not recommend a cellulosic route. For cleanliness and the addition of adding hydrogen into a weld, even though it can be baked out. All that's being thrown up for discussion. But a low hydrogen route pass, everything's going to be driven by hardness. Okay.
Yes.
And so if you think about trying to run a uphill low hydrogen route pass with a stick electrode, your heat affected zone hardness is going to be through the roof. Therefore, because you can't keep the heat input and the kilojoules down, that's a no-no. I would steer away from that, trying to maintain heat input as low as possible to maintain a hardness that you can live with, especially if people are trying to do this in the as-welded condition without post-weld heat treat. And all that's got to be discussed. What do they recommend? Do they recommend post-weld heat treat to soften that so you can guarantee a weld that's got a hardness level that, for the production welding that's going to be safe to the for use in the future? Though all these things and all these questions are what's going to be kicked around in these conferences, and there's going to be a lot of good discussions based on this, and we've got a lot of good speakers coming in that are already in the middle of designing this. Some of them sit on the code committees that are being driven. ASME has a code just for hydrogen service. And so we've got people from those committees coming in. We've got people from other countries coming in that are already doing these things. And the question is always going to be driven by money. How much do they really want to spend to do this, to do it right?
Yeah, at the end of the day, that's always, cost is going to supersede everything. And it's going to be a lot of private investors that are going to have to fork over the money to get this stuff done.
That and the government's kicking in these billions of dollars of subsidies for this, but they need to be kicking over billions of dollars of research money too, to drive, because we can say we want to do this all day long, but if we don't have money to do the research to put it into code, then most companies do the minimum. If the code says this is it right here, this is the minimum requirement, they're just going to skate through the minimum. With hydrogen service, do you really want to do that, or do you want to supersede the code a little bit to maintain a higher level of quality, so you don't, to reduce your safety factor on the back end? That's the big question too. Yeah. Or but that's part of the reason why we're having this conversation today, because this is not going away. It's like Bill was saying earlier, and that's all you hear about now is hydrogen, blue hydrogen. That's what everybody's trying to, companies are asking questions. They're wanting to know what to do. And there's no technical papers really that are out there. A lot of the stuff we found was done in early 2000s by companies that are already doing it. And so again, we're reaching out to our European friends, people in Asia and Australia, all these countries that are, some of them have already been doing it. Some are trying, they're on board with, like the US right now. We're starting to get into it. So, and it's a global thing. It's not just happening domestically. It's being pushed everywhere. If you get on LinkedIn and you're tied into any of the different societies and whatnot, you'll see at least once a week another hydrogen project that's being kicked into, it's getting funded or they're looking at this stuff to. And then again, my question is have y'all thought about the welding? And that's always an afterthought.
Yeah. And a lot of people would say, why don't you use like a plastic or a polymer or some type of, manufactured, well, I mean, it's going to have to be manufactured from petrochemical, but like a plastic or a polymer. And because hydrogen is such a small molecule, it can literally seep right through the pores. So, I mean, even at the connection points where we go, and we have like seals and valves and all that stuff that are made from plastics and rubbers, those all have to be, I mean, there's got to be a lot of thought put into that too. How are we going to reconfigure those? What materials are we going to use in the valves and the seals and everything to where hydrogen's not leaking? Because it's colorless, it's odorless, very similar to acetylene and propane. Like, we have to add different odors to this to make it detectable because you can't see it.
Correct. Well, we have another challenge. We can bring all these people together, but I'm betting it's kind of like the steam turbine repair business or manufacturing business. Almost everything is proprietary, and they do that for a reason, because that's their bread and butter. I would be willing to speculate that the people that are already doing it are not going to be real talkative.
No.
Because if they're having good success, they don't want their competitor to know. And okay, I understand commercialism and this, that, but our challenge is going to be to find some folks that will talk about it. And in getting the speakers, we've been very fortunate, and some heavy hitters have agreed to come and talk and say what they know. And that's so valuable in something like this. I'm sure that the folks in Europe, they know they can do it in their sleep. We've got some folks in the Gulf Coast that know what they're doing, but they're not talking about it. And it's rare that you see a technical paper or a presentation where they do fess up on what they do. Now, Air Liquide, for example, and Praxair, they have published some information, but it's, when you start looking at it, say, well, okay, this is where they started and this is where they ended, but they left out the middle.
You get a little vague in the details.
That middle is what we want to talk about.
Yeah. Yeah, it's an interesting concept. I mean, switching over from a fossil fuel that we've been using for hundreds of years, and just completely shifting gears and going into hydrogen, which we really don't know enough about, even though there's been research and stuff done on it, like I said before, like since the 1960s. And now here we are, like we need to start implementing this, and we don't even know heads or tails. Not sure where to start with it. And then even once we get that stuff sent through, is it going to be used by the power systems? I mean, we're going to use this for household electricity, driving cars, everything, and then you got to talk about the ratio. Like, hydrogen's highly flammable. However, you need 3 times the volume to equal like what we're currently getting out of a liter of gas. So, or 4 times the volume. So you need 4 liters of hydrogen to equal 1 liter of gasoline. So can we produce that much hydrogen to be able to sustain everything? And then at that point, is it cost effective? I mean, you look at a gallon of gas right now, if I had to pay 4 times that amount for a liter of hydrogen or a gallon of hydrogen, is that going to be affordable at the end of the day for the American people? Can we manufacture enough hydrogen and transport it, and then separate it and divide it up, compress it, liquefy it, and send it out at a cost effective value?
Well, and that's being discussed openly in the open literature, and people are saying, we can't get to where they want us to be by 2030 or even 2050, because we just physically don't have the wherewithal or the resources to make that much hydrogen. Because something's got to give. We've got to compromise and give up something else, and we're not real forgiving.
No, it's going to take a lot of power to generate power.
Exactly.
And I mean, like, everybody wants to go solar and wind and all that, and that's great, unless you live in like Washington State and it's raining damn near year round and you don't get a whole lot of wind because you got big trees blocking everything, or you live out in Jersey where 360 something days out of the year you got an overcast, or you're living in Northeast and it's just constantly frozen for 6 months out of the year. You're not getting a whole lot of use out of your solar panels or your wind turbines. So now how do we come up with something that's mutually beneficial? I mean, obviously Florida's a sunshine state, so we can do a lot of solar over here. Y'all got a lot of wind out in Texas and Arizona and all that. So yeah, set up some wind turbines out there, but I think it's going to be several solutions, and then hydrogen is going to be like, it's going to accompany that. It's going to complement all of this stuff. I don't think there's one resource that is like the end all be all. It's going to replace petrochemical.
No, I don't think it ever will. Not in my lifetime anyway. But I think it can be where it can be used and used effectively. and economically, it's a great idea. You know, we now, as an example, in welding, helium is tough to get. Well, people are going back 50, 60 years and using hydrogen blends with argon. It works great. In fact, it cleans better. But there was this stigma, and you said it right out of the chute. Everybody, when you say hydrogen, everybody thinks of the Hindenburg. We're not talking about the Hindenburg. Whole different ball game here. And could it do that? Well, sure, if we're not careful. But if we're careful, that's not an issue, or shouldn't be an issue. And the fact that we haven't really blown anything up, I think that's a good sign.
Put a check in the positive box on that one.
Yeah, for sure.
Yes, it's an interesting concept. I was talking to, I had Lori Kuiper in here last week, and we were talking a little bit about, hydrogen and all that stuff. But so I was really looking forward to this conversation and learning more about it, because, I mean, if that's like the next new thing, we got to get ahead of the power curve. And it sounds like we're, compared to other countries like Asia and Europe, we're already behind the power curve. I would imagine that India is already, developing stuff right now as we speak, if they already have it.
I don't know.
Well, so I think you're seeing hydrogen in countries where they're more concerned about the environment per se. You've got countries in Asia and around the planet that are still burning coal at an alarming rate. And the ones that don't mind burning the old world fossil fuels, they're not going to look at this technology as much as other. I don't want to be disrespectful, but more developed countries that are being driven by their governments to run cleaner. So Europe, Western Europe, they've always been on the front end of this because they got more people in a smaller space. They got to do more with less, right? And in certain countries in Asia, they're ahead of the curve a little bit too, or they're a little bit faster to develop things. Where sometimes I hate to say it, but in the U.S. it's like the Wild West. We're the last of the buffalo, man. We're out here still doing things the way we've always done them. Not that it makes sense, but it's just the way we do things. So we're kind of not behind the eight ball, but we're getting on the bandwagon. And it's going to be interesting to see how we develop that. We're everybody you talk to that's working, colleagues that we have that are in the middle of developing projects for hydrogen-based service. They're going out abroad trying to find out what everybody else is doing to see if what their track of thinking is on board with that. But I think you're going to see hydrogen first used probably more so in the power industry, because from what I've seen and read, like Bill was saying, a lot of these turbines and stuff and infrastructure and power plants, the gas-fired power plants, they're already set up to burn hydrogen. So then the question becomes okay, the pipeline carrier that brings the gas to the plant, does that pipeline, can you, redesign it for hydrogen-based service, or do you just start adding hydrogen blends to that gas to sell to that customer, right? And then before you start thinking about the other usages, like, in automobiles or other things that everybody else is looking at. But the fastest way to input this into the industry would probably be in the power industry, to replace natural gas as a fuel, and start blending it with hydrogen, because the infrastructure is already there.
All right, we're going to go ahead and take a quick commercial break. This segment of the Arc Junkies podcast is brought to you by Strong Hand Tools. Upgrade your current fabrication setup with Strong Hand. Their fabrication tables and tools are built to withstand the rigors of the workshop and provide a stable, secure work surface. From clamping to welding to cutting and fabricating, Strong Hand tables and tools will help you get the job done faster and more accurate. Trust Strong Hand for all your fabrication needs. Shop now and take advantage of 10% discounts on tables and 5% discount on 5/8 tool packs when you go to stronghandtools.com/promo. We're also brought to you by Everlast Welders. They just released the all-new Typhoon. It's a badass stick and TIG machine packed full of advanced features and functions, including all-new industry-first waveforms. The Typhoon is available in a 230-amp or a 325-amp version. Both feature a 7-inch high-def color user interface screen, AC/DC stick and TIG capabilities, pulse adjustment, and 5 AC waveforms. The Typhoon is available right now for pre-order at everlastwelders.com. And as always, be sure to use code word ARCJunkies in the comments section at checkout You get that free Nova foot pedal and TIG torch when you buy any machine that comes with a stock foot pedal. Everlast Welders. Weld mean, weld green. Now let's get back to the show. Yeah, that was going to be one of my questions. Can we use hydrogen? So let's say we don't use 100% hydrogen. We're not transporting 100% hydrogen through these pipes. What if we do like I guess they said like a 20% mix is relatively safe. Can we do an 80-20 mix with hydrogen and another fossilized fuel and use that as an additive, very similar to what they did with ethanol? You know, they're adding 10% ethanol to the vehicles and everything to kind of reduce emissions and get to, you know, practically a zero emission value. But can we do that in the power plant industry? Can we say, hey, we're going to give you an 80-20 mix and we're going to reduce, not eliminate, the carbon footprint. And, this is going to be safe and effective. And, the current infrastructure is going to be able to support that. And, we're still doing our part. And then we can rely on, completely clean energy as far as like windmills and solar and all that stuff.
Well, there's another consideration there, and you walked up to it and stopped at the door. Can the equipment handle it? You start putting hydrogen blends in or mixing hydrogen with LNG or natural gas, and the temperature's going up. And most of our equipment has a finite temperature that it can go to, and then after that we've got creep problems and things like that, especially on a turbine, whether it's the steam turbine or the turbine, the jet engine, if you will, that drives it. So we've got to look at that now. At least two of the combustion turbine vendors, have designed and actually have one in service, at least one, a thing that uses a hydrogen blend with the thing, but it's almost all super alloy. It's not like your father's Oldsmobile. I mean, it's really high tech because it's running at a much higher temperature. Now, can the rest of the system handle that? Some may. Some absolutely will not. So that's another challenge that the designer has to come up with. And we just can't say, oh, well, we're going to switch to hydrogen. Well, we can melt it down because it's just about that dramatic. So this is going to be an evolution. I know that you say, oh, that takes a long time. Well, yeah, this is going to take a while. It's not going to happen tomorrow.
Right.
But there are those considerations that we have to take into account.
But that'd be the same considerations if you were going to completely switch something out. Because if it can't handle a 20% increase of hydrogen into the system right now, if we switch over to complete hydrogen, we're going to have to rebuild the entire structure, all the piping and turbines and everything that's supporting it to where it'll be able to take 100% of that hydrogen and do something with it.
I will be very surprised. I'm no chemist. I don't claim to be. I'm just an old welding engineer. But I don't think we'll be burning pure hydrogen. Not for a long, long time.
So it's going to have to be a blend or a mix.
Yes.
Yeah, because, the biggest thing we have right now is 90% of the fossil plants that you have that are burning, like cogeneration style plants, those are not designed to last as long as like a coal-fired plant, right? So they got a shelf life. And we're already... most of these, what most people don't realize is in the power industry, most of those plants are already beyond their life expectancy. Okay. So now they're doing that. Every time they have an outage, they go in, they do fitness for service. They've got people coming in and running design calcs on what they have, looking at the metallurgy of the base metal in its current state. And they're trying to predict how much longer it can last, at its current state.
Keyword
and like
predict.
Bill said, yeah. Now you add hydrogen, you increase the temperature, right? Mm-hmm. Even a little bit, a small percentage. Now, whatever, if you think that plant's going to last 10 years, what is that calculation now going to be when you add that formula, right? So are we prepared, or has the government prepared to say, yeah, we're going to just shift into this? And of course, they're real good about kicking in subsidies and everybody's going after the money like it's on fire, right? And that's great, but to actively really do this, I think we're still, even though we're getting calls and people are being asked to give budgetary quotes for construction right now, I think those budgetary quotes are going to get blown out of proportion before somebody starts to break ground and build something to start creating this monster. Because when they find out what the real cost is going to be, they're going to have to sit back and say, okay, are the taxpayers that, basically pay for these subsidies prepared, to go along with this? And that's something that's going to be, it's not going away. But how we approach this is where, that's why we're having these discussions, because nobody's talking about it as much, Yeah,
I mean, I don't think enough people know about it. Now, with the government subsidies, if they're willing to pump out all this money, I mean, that's the carrot. Where's the stick? How much time are they giving people to say, hey, here's your subsidy, do something with it? Or do they have like a finite, timeline for it? Like, hey, within the next 5-10 years, you got to have, X amount of progress being made in order to receive this subsidy.
It's not like solar and wind. If you kick in a subsidy for a wind farm, I mean, you could have a wind tower built in a couple months. It's the infrastructure to that. It's easy. Even with solar, they're popping up here around the Gulf Coast area like crazy. They're just, one month you got a fertile piece of soil there and some farmland, a couple thousand acres, and within a couple weeks they're building a solar farm, and they just tie it into the grid. Don't have to worry about anything. I think you're going to have to start looking at hydrogen almost like a nuclear power plant. Yeah, we want to go this way because it's cleaner energy, but it may take 10 years to get to that point. Yeah. It's not just a turn on the switch type of deal like people are accustomed to. They're going to have to be patient.
Well, these subsidies, it's kind of interesting because the colleges, universities, and the national laboratories are all fighting for this money and they're vying for it. And that's all well and good. But there's a heck of a lot of water has to go under the bridge between the R&D side and actually going out here and striking an arc.
Yeah.
And it's always been frustrating to me, and this is nothing new. It's been this way for decades, is that instead of doing parallel funding to the people that are actually going to have to do it, as well as the people that are doing the R&D, there's a lot of things that, for example, Scotty and I could be working on, and we had an idea what we were supposed to work on and get a jump on it.
But you won't get that information until the college releases their studies after, 10 years. Now we're, 15 years behind the power curve.
And that's exactly right. And that's what's so frustrating. But if we put in a request for a grant from National Science Foundation or DOE or whomever, they go, what are these guys? They don't know anything about this. And it's like Amaret. Good case in point. She's trying to go after a grant. And they're asking her questions that, quite frankly, I think they're stupid, but it's the way it works in the grant world. And I think that's what we got here. We saw the fiascos in the past where the government was going to bail everybody out. Well, yeah, and all those companies went belly up because they weren't looking at the big picture. And I think that's kind of what Scotty's getting at here, and that we've got to look at the whole ball of wax, and everybody needs a seat at the table.
Yeah.
And having this podcast like this, somebody out there may listen to this, and it just takes one person to say, wow, that's a good idea. And he knows somebody who knows somebody, or she knows somebody who knows somebody, and we get the ball rolling. That's why we're doing what we're going to do at this workshop, trying to get people involved, all different types of people, engineers, scientists, craft if possible, the whole 9 yards, because it's going to take all of us to do this. And we've learned that over the years, and I guess we're comfortable enough with ourselves to say, yeah, we don't know. We're going to find out.
Yeah, very, very similar to our current problem with energy. It's going to take, it's not going to be one solution. So you've got to get all these different groups together, code committees, colleges, people that are actually doing it, engineers, all the way down to the welders, to figure out exactly how we're going to solve this problem. Because I can guarantee you, nobody is anticipating how much it's actually going to cost. I mean, look at the Alaskan pipeline. They're like, oh yeah, it's $1 billion job. Well, $9 billion later, when they finally completed construction, it's going to be the same thing with hydrogen if you don't start getting people involved that, really know how to do this stuff. And like you said, there's really nobody that really knows how to do it. So if you just fund a couple universities that aren't actually out there in the field, you need some people that have had hands-on experience with the different types of alloys and welding processes to be in that room with them and say, that's not going to work, and here's why.
Right.
Correct. And that's what this whole hydrogen welding workshop is all about. There's as many questions as there are answers, and it almost seems like to me that when you get some questions and you answer those, by answering those you find 3 or 4 more questions. There's a lot of research and development been done, a lot of data been gathered since the 60s, as you guys mentioned. But there's also a lot of technology we have today that we didn't have back then. And one of the things that I think about is, if people knew back then that we would be going down this road, I'm certain that the pipelines, could have been constructed a little bit differently, maybe with a little bit different material. I'm not certain as to how that goes, but I think we have to. It's looking at the big picture. It's not about jumping in and trying to figure out as we go. You really need to have a good, solid plan, for what if, and that's part of why, Bill and Scott wanted to put this workshop on and gather these, technical experts in the field, some of which have already been down this road and a lot of which are involved in testing and data and R&D and things like that moving into the future. But there's a big picture here, from procurement, material, evaluation, material availability. What can we do what can we add to the pipelines that we have in service? You mentioned hydrogen, mixture with another source, and yeah, like Scotty was talking about, the longevity, the lifetime of these pipelines are calculated around what's going through them now. And when you put an additive like hydrogen in there at whatever percentage, whether it be 20, 10, or whatever comes down the pipe, it severely reduces the longevity and the lifetime of that system, which comes in its own problems. And I think there's a lot of questions here, and I think that a lot of the answers hadn't been heard, and that's part of this workshop and part of this team, coming together, getting in a room, and with a lot of super intelligent people that have been involved in this arena for a long, long time, many years, and combining that information and bringing the real truth to the surface.
Well, a good example of this, I sent the notice of the workshop to some of my friends at the Electric Power Research Institute. And the first question they come back was, well, are you going to talk about ammonia? I said, what do you mean? I never thought of it. Well, the power companies are looking at, that as an alternate fuel and this thing. There are so many, this is like a big tree with all kinds of limbs and branches and leaves, and it keeps growing. So part of the challenge is going to be keeping a focus on something. What that something is, right now, I can't tell you what that is, but I think we're going to have a better handle on it between now and the workshop, and then the workshop's going to produce some real fruit.
So, some of the things that we've done today, I mean, we're looking at the near future, with SpaceX of, having vacations on Mars and things like this. And now we're looking at hydrogen pipeline. I mean, this world is transitioning into a much different place than all of us grew up in. And I think with that thought process, and the sky is the limit, anything that's put in our face right now, we know as individuals that we can figure it out. What we really have to do is put silo in information and create workshops, create events and educational arenas that can educate people and take all these silos, combine them like we're doing here, and bring out the real product. Talk about the what ifs, talk about the safety factor of it. That's huge. Talk about material availability, talk about automation versus manual and what that looks like, and setting these jobs up the right way. There's a lot. There's just so much to talk about.
And this conference is going to be probably the first of a couple, where we wanted to kick one off this year. We were trying to do it earlier this year, just couldn't get it with logistics. But, the way it's looking is I'm thinking that this will probably be a bi-yearly thing, or maybe a once a year thing until things get picked up off the ground more. to try to get a bunch of people together, create a reason for them to get together, to try to get the information to people that need it, so the decisions can be made, to how we're going to proceed in the future. So when the companies that these people work for are asked to, quote and bid this work to design things for hydrogen service, that they say, yeah, I actually attended a conference about that, and we have an idea how to weld it. So when y'all get ready to, to estimate these jobs, please, run things by our, weld engineering department, so we can kind of give you some, some costs and safety precautions and whatnot to how to proceed. Because, we don't want to be in the position where companies bid this work and then they get awarded a job, and then they're, and then the poor welding guy is like, hey, here, we got this job. We're going to start in a week. We're mobilizing. And well, what are we doing? Oh, it's a hydrogen pipeline or a hydrogen, compressor station, or, it's a whole plant designed for hydrogen service. How are we going to handle that? So we need to be ahead of this thing. And that's the most important thing that we're trying to put together here, is just a group of professionals. And maybe it becomes an event that, just to get things going, because I'm so sick and tired of being in this industry and being the last person to know about something. And we always get asked at the 9th hour, hey, can you make something happen? What are we doing? How long did you know about this job? Oh, man, we've had this job about a year, and now you're in a hurry. So we as a group, we decided, hey, man, let's just get ahead of this thing. And let's, hey, if we may do nothing but generate more questions in October.
We haven't talked about the other elephant in the room, and it's supply chain.
Yep.
Once we decide what materials we need, can we even get them in our lifetime? It's not unusual now, but 12, 14, 26 weeks lead time on certain weld metals. Yep. And, when one of the, I call them the big box stores, big manufacturers, runs out of 70S6, you got to wonder, what in the world is going on? That was just last week. And and I doubt that we're going to have real sophisticated weld metal on this, or I don't think we will, but I could be wrong. But if we have to have a special, you're looking at 6 months lead time, minimum. So you can't, like Scotty says, show up to the job. Oh, we got to do this. I said, well, the weld metal will be here 6 months after the job's done. Well, it doesn't work that way. That's reality nowadays. And we got to think about the pipe. If we don't use an existing line and we put a new one in, supply of pipe and fittings and other components is not trivial these days.
Right.
So there's a lot of factors here. It's like I said, it's that tree with all these branches, and they all meet at the trunk, and you hope the trunk's big enough to hold it all up.
Yeah. I mean, if you think about it, like, let's say you get the material, you got it on hand. Somehow it's the exact material we manufacture in the U.S., and the same thing with the filler metals, and it's just easy to get. Well, now we got to get all kinds of new permits and leases and land agreements and all that other stuff, and go through the EPA, and we got to get, all these different permits and everything just before we can start even cutting a trench in. I mean, you got to think about that stuff too. What's the lead time on that? Like, how soon are we going to be able to implement this? And then once we get it all implemented and flowing, like I said before, are these facilities going to be able to sustain it? I mean, are we putting the cart in front of the horse? Do we build the infrastructure first and then figure out how to get the product there? Or do we figure out how to move the product and then figure out what to do with it once it gets to the end of the pipeline?
Or do we put the wrong infrastructure in to begin with, and realize later on with evaluations that it's the wrong material? I think that's another good thing about this conference is connecting people. It's not a bunch of engineers in a room, no pun intended, but not a bunch of engineers in a room running calculations based on data. This is processes. These are people involved, that's going through the testing phases, the strength test, all these tests that have to be done to prove this material. This conference is bringing this conference is bringing all those things together, and there's conversations with everybody involved. And that's what I like about this, because when you talk, to an engineer, there's one conversation, and you talk to a practical person that's implementing this stuff, in real environments in the field. That's a whole different conversation. And I always go back to the saying, you can draw a horse on paper, but then try to ride it, right? And when you connect, practical people utilizing, these processes and material and bill of material and piping material in the field, and you connect them with the engineering, and you come together with an expo that's going to flush out all those questions and deliver a lot of answers.
Well, I think Scotty was absolutely correct, and this is just going to be the first of many, because I guarantee you we'll have more questions than we have answers at the conclusion of this workshop, but it's going to point us we know where we need to go looking.
Yes.
And or at least we'll have a better idea. And I'm excited about it. I'm looking forward to it. I know it sounds weird to get excited about hydrogen, but it's it's been around forever. It was like atomic hydrogen welding is only 100 years old, and there's some folks looking at that again. So we kind of go full circle on these things, and here's one that to try to lower our CO2 emissions, going to look at hydrogen. But as my business partner says, there's always unintended consequences. And those are the ones we got to look out for.
Mm-hmm. And the good thing about this get together we're going to have is you've got a lot of different industries, pipeline, midstream, petrochem and refining, power, people, industries looking at hydrogen and how they're going to use it because of the subsidies. And what we're trying to do is bridge that gap to where we want people from the pipeline industry at this event. We want people from the petrochem and refining, group from this event. We want people from the power industry at this event, because at the end of the day, if depending on what kind of plant you have, it's coming to you in a pipeline. Okay. So everybody's involved. So if we can just connect the dots and get everybody in a room, kind of like an unofficial task group for hydrogen, is what we really want to create. We want everybody involved, and we want everybody to network here so everybody's on the same page. Because at the end of the day, we don't want the power people going one direction, or maybe we don't want the Europeans going one direction. And why in America are we trying to go a different direction? Why are we trying to reinvent the wheel? So, you know what I mean? It's just getting everybody together to put their heads together, be like, okay, how are we going to proceed with this in a manner that's going to work from a commercial perspective? Because if we can't figure out how to make it work commercially, it's never going to get any ground. The taxpayers can only handle so much strain. And if we're going to put billions of dollars into this, okay, great. But let's do it in a manner to where, we get more bang for our buck, as a taxpayer, and we do it safely. Yeah. So the public doesn't have anything to worry about, when there's a pipeline in their backyard, it's got hydrogen flowing through it, or a plant right down the road. Some of the, if you Google it, you can find some incidents where they've had pipeline failures or line failures in plants that had, pure hydrogen. It's not pretty, so people, you see all these activists and whatnot freaking out about a crude pipeline or a natural gas pipeline. Now we're talking hydrogen.
Yeah.
Yeah, it's safer and cleaner, but there's a price to pay to get to that. And how do we avoid the safety risk, and so, we just want to be ahead of this thing and not be behind it. We want to generate the conversations and get people talking about these things and get to a point to where, we feel comfortable as a welding industry attacking this situation,
I think another thing we got to consider is, once we kind of figure out what, exactly which process we're going to run, how we're going to do it, the material and all that information needs to be passed off to the schools, because as it stands right now, there's a huge shortage on welders. So that information has got to be brought down to like the different trade schools to show students how to do that. So once they finish up the program that they're in, they can get right out there and start performing the work. Because, we're already behind. So from the day that they say go, we're going to be that much further behind. So as we develop these processes and procedures, that information's got to trickle down to the schoolhouse. Otherwise, you can have a bunch of kids coming out knowing nothing but, short circuit MIG on 1/4-inch plate, and they're not going to be worth a damn once they get out on the job site. If we tap into this industry, this hydrogen stuff, regardless if we're going through existing pipe and making repairs and shoring that back up, or we're building a completely new line, Same thing with the infrastructure. We're going to have the bodies to be able to go in there and do that, and make these welds and either repair and replace or install new.
Yeah. Well, there's another issue there. No, it's a huge issue. And that's the instructors that teach these students or people. They're woefully challenged, to put it that way. I'm amazed that, like you say, they come out with short arc. Now they think they can go well on a pressure vessel. Yeah. Wrong. And unfortunately, many of the instructors have not connected those dots. So we've got several challenges in the supply chain, and that includes people.
There's a lot of issues when it comes down to that, but I think we also need to, as part of this stuff, get the instructors more involved and kind of open their eyes. A lot of them, they've only done one process their entire life, and now they're trying to go teach, the 5 major processes in a school setting, and they can get by with it, but they don't have the practical application behind them. So, opening up workshops and webinars and seminars and stuff like that, and making it easily accessible for the instructors to access to get that information, because the school's not going to foot the bill for it. Most of the schools, they're running on a shoestring budget anyway. And, the welding program, that's the redheaded bastard stepchild that we have. Nobody wants it, but everybody needs it. But so we got to have it here at the school, but we don't want to put any money into it. Make these, education seminars and stuff free or severely discounted for instructors so that they can get in there, get access to that information, and then disseminate that back to the students. And then have the industry work with those local schools. Send 2 or 3 of your guys that can go in there and teach that process, get that program shored up, and like, no pun intended, create your own pipeline of workers that are coming out of that school system. Because there's not enough people out there that can do it. Scott and I, we've talked about it all the time. You got a bunch of schools out there producing a bunch of sparkle babies. We don't need that. We need actual welders, educated welders that can come out there and, start at work, on day one without a whole lot of supervision.
I think there's so many chunks to this, Jason, that, the education process is one chunk. That's a podcast that could go on at least once a month annually. I think the material availability is a part of it. I think the engineering and evaluation is a part. Honestly, you could create 2 podcasts a week for as long as we are on this earth. And I don't think there would be enough discussions on it. But and again, as we've done on this podcast, we've answered some questions, but out of those questions is another whole side of it. And it's so much greater when you take all the silos of people, even on this call, and we combine them, and you have one person that has, one side of the fence and another person has the other side of the fence, but there's 2 totally different visions on this, and coming together, we answer questions, ask more questions, and we begin to learn, and connect in ways that we haven't by silo. And that's why these things are so great to me.
And I think that's what it's going to take. It's going to take people from all over every facet of the welding industry to come together and say, hey, I'm not a one-man island now. I'm relying on, the engineering. I'm relying on the people from testing. I'm relying on the people from education. I'm relying on the people from materials and methods. Like, let's all get together and figure this out. Because at the end of the day, there's going to be enough room at the table for everybody to have a seat and work this whole thing out. And it's just going to benefit the entire country. This could be our next industrial revolution.
Amen.
Well, and the thing that that concerns me is you got to be real careful about this fine line we're toting about trying to get the workforce up to that, ninja level of welding that we want them to be at. We need welders at the best of their game to do this, but let's be practical. We need to be able to do this with the workforce we currently have. Okay. So it's going to take implementing technology that we already have that's in place today. So if you told me tomorrow, Scott, we got to build a pipeline or a plant tomorrow for hydrogen service, I'm going to put my hat on and be like, okay, what have we done in the past? Not the future, because we don't have time. What have we done in the past to be successful with a workforce that we can use today? You're going to look at processes that, you can use like modified short circuit, GMAW. Yeah. That could be a Ferronius, a Lincoln, or a Miller type machine, an STT, RMD, CMT for diameters, large enough to do that. Anything below that, it's going to be TIG. Okay. Well, if we've got a workforce that struggles with TIG, we're using two hands to be consistent and put a very consistent route in, now we're looking at a wire-fed TIG process like tip TIG. To where you can implement that quick and fast. Training is not long. It doesn't take long. You can take a welder that doesn't have 20 years TIG welding experience, and you can have him putting successful root beads in, because like Bill said, the most important part of this is going to be on the product side, the root, the hot pass.
Yes.
If it's got any thickness to it at all, once you get beyond that, it's just filling and capping. You're really not going to do much to really affect the weld area as much as you were on the product side. So that root and that hot pass are going to be the most important thing you can do here. Questions are going to be, should we purge that, even though it's carbon steel, to get a cleaner root pass? All these things are going to be, and that would also help to improve the weld, to make it a little bit easier for the welder to make that weld by adding a back purge on carbon steel, which we know is not required, but we're talking about having a super high purity weld here. Now how do you do things? How do you back purge miles of carbon steel to help?
How do you get
everything
the dams
out?
in there to purge everything?
So, some companies have got it figured out with their internal lineup clamps and stuff like that, or pull through that do all that already. The technology is already here. So, but how do you use what we have today to be successful in the near future? And then what do we do in the near future to be prepared for the future? It's like I was at the AWS Pipeline Conference, the last one that was held before we did the one last year in New Orleans in 2014. There was a colleague there from Floor. He works out at that Hanford nuclear site. You know him,
Gary
Bill,
Cannell.
I forget his name. Yeah, Gary Cannell. He did a presentation on EBW welding? Of pipe. There's no heat affected zone. Well, for hydrogen, if you're worried about high hardness, that's where you're going to have high hardness is in the heat affected zone. They don't have a heat affected zone. And he was talking about, that this was 10, 12 years ago commercially to even, and there's been talk, people are trying to make girth welds with that type of process. That process, you may start to see things like that in the future become mainstream, where, it's getting commercially viable to shrink that package to where you could bring it to the field to make welds like that. Because currently, I think you can only do that in a laboratory or a shop setting because the equipment's just massive, the power requirements and all those things and the equipment. But now, with government subsidies, that may be the future. We don't know. But we're not going to be able to do that in a year to 2 years. That's 10, 12 years down the road. What can we do today to make these welds successful? That's what we need to be talking about. And those things we're going to be bringing up in October and challenging everybody. Look, it's great to come up with these great ideas of how to do this. But remember, your companies have to they got to be able to afford to do this with the workforce we have today. So how are we going to achieve that? That's one of the most important things, as well as, and training comes to that. So how can we do minimal training to be successful?
Well,
in the near future.
Yeah, the engineer's responsibility, from my perspective, is we have got to figure out a way to design forgiveness into the approach, because we know we're not going to have all golden arms out there. So we need forgiving weld metal, we need forgiving materials, we need forgiving procedures, and as like Scotty says, take what we've got and put it to work. Who knows? We may be looking at a laser. No, theirs are getting affordable now, and to get written to, so we don't have a heat affected zone, or we have a minimal heat affected zone. There's just a lot of different things, but it's almost as if we're going through a woods in the middle of the night without a flashlight, and we're bumping into trees. So there's just a lot of questions.
Exactly.
And we got to know what the target is.
Then we got to look into the different inspection techniques. How are we going to inspect this? Because hydrogen is much more susceptible to leaking. So we got to come up with a little bit more precise, methods of testing and stuff like that. That's going to be able to pick up hydrogen leakage and, you know, all the safety and everything after everything's put in the ground. You know, we got to have stuff in there to detect leaks, and there's a lot that's going to go into it. So I think this is going to be a pretty cool workshop. So it's
going to give new meaning to a hydro.
Yeah.
Everything will become recycling.
Exactly. So what are we looking at? The hydrogen workshop is actually Thursday, October 12th, 2023, and it runs from 8:30 to 5 p.m. out in Lyondell Bassel Building at San Jacinto College. They're in Fairmont Parkway out in Texas. So
yes, sir.
It sounds like it's going to be a good time. I mean, I'm looking forward to, you know, coming out there and attending because I don't know nothing about hydrogen. Like, it's a very interesting topic. And I mean, if that's going to be the future, you know, you got to stay ahead of the curve. You can't sit there and be stagnant. You know, if this technology's coming, you can't keep training people how to do stuff we've always done, because that's not the route we're going anymore. We're changing gears. We're getting into something completely different. So you can't stay stagnant in this industry. It's an opportunity for a lot of people to grow professionally, and there's going to be a lot of business opportunities in it for people.
Agreed.
No doubt.
Well, heck, I appreciate you guys coming out here and kind of sharing the information. I'll go ahead and drop the link in the show notes if you guys want to attend the workshop there. It'll be in the show notes. Just click on that. It'll take you right to the website. You can find more information on the hydrogen welding workshop.
Thank you, Jason.
Thank y'all.
Yeah. Thank you. Thank you very much, Jason.
All right, ladies and gentlemen, thank you for tuning into this week's episode and listening to the panel discussion on hydrogen as an alternative fuel source. We hope you found the conversation informative and insightful. If y'all have any comments, questions, or suggestions for future episodes, please feel free to reach out to me via email, show@arcjunkies.com, or on Instagram @arcjunkiespodcast. Don't forget to subscribe to the show on your favorite podcast downloader app to stay up to date on all the latest trends and innovations in welding. Hope you'll have a great rest of your week. Stay safe out there, and until next time, make every weld better than your last.